Right, hi there everybody. Today we're going to look at some trigonometry and Pythagoras in 3 dimensions, alright? So, hope you're all switched on and hope you're kind of familiar and comfortable with trigonometry and Pythagoras, because I guess you need to be if you're going to do the same in 3-dimensional shapes, alright? So what you're going to look at, you're going to try and identify where the right angle triangles are and what numbers you can see from the 3 dimensions looking at them. Alright, so find the length of the diagonal AG. Okay, so highlighting the AG is probably quite important. All right, so you can see it. So it goes right across the middle of the shape, right across the diagonal. And I want to work out the length of that. Okay, so I'm not necessarily going to go straight into doing that. There is a bit of a trick to doing this, but I'm trying to avoid that at this point in time. I want to show you really what the expectations are. So if you think 3-dimensionally, in order to work out that one, then I'm looking at this triangle that goes across the middle here of the shape. So I need, if you can see where my cursor is here, I need to work out this distance here first, and that's going to give me that shape essentially. All right, and that's what I'm going to do. So what I'm going to do is going to do Pythagoras twice. So I'm going to do 5 squared and 3 squared to get this distance, and then once I've got this distance and this distance squared will give me that diagonal. All right, so let's have a look. So there we go. So that's the triangle we're looking at. So looking at the base of the shape, looking at that triangle that I can see, I've got that triangle there, which is 5 and 3, and I want the diagonal, which is AC, isn't it? So 5 squared plus 3 squared square rooted is going to give me root 34, all right, which is AC, and which is going to give you that. And then to work out AG, this is in the next kind of triangle, I've got that number which I worked out. The height is 4, so Pythagoras again, so it's going to be the 5.8309, or root 34 squared, plus 4 squared, square rooted, is going to give me root 50, which is going to give me 7.07. All right, so that's what I have for AG, the length of the diagonal over there. All right, a bit awkward, but of course it's about making sure you can spot the triangle still, and that's all we're after in 3-dimensional shapes. Okay, so let's have a look at trigonometry in 3D as well while we're kind of here. Same kind of process. If you think about Pythagoras or trig, we're still looking for right angle triangles in both cases. So we're still looking for the kind of same idea, but of course we're now going to apply trigonometry when I'm looking at it. So find the size of angle GAC. So labeling that first of all, or seeing it, is going to be there. Okay, so we can use probably what we've just done to support me in doing this, because I've already got the piece of information which is AC, and I've already got AG. So actually I've already got an awful lot of that information by just using Pythagoras, haven't I? So looking back, that was the triangle we had at the bottom, which gave me 5.8309. So we already kind of saw that one. And then I've got this. All right, so at this point, I don't really need to work out AG, which is what I did last time. Because I've got 2 sides, I can go straight into trigonometry to work out GAC, the angle in the corner. All right. So what have I got? Well, let's have a look very carefully. This is the opposite, and this is the adjacent. So it's going to be tan. And because it's the angle, it's going to be tan to the -1 of opposite over adjacent. So tan to the -1 of this over this, which is going to give me 34.4 degrees. All right. So with this question, whilst it's 3D trigonometry, it still requires Pythagoras for you to get there. So your understanding of Pythagoras and trigonometry, again, certainly for those kind of more complicated questions where it's in 3 dimensions, you need to be very, very secure on them. All right, so please feel free, go to maths-school.co.uk and do some additional practice questions on some of those. Obviously, some are more complicated than others, but obviously if you want to come back to the video and revisit, then obviously you can at any time. Thanks for listening.